Boardrooms routinely demand better data governance, but a high-level corporate mandate alone does not secure a physical server. Chapter 2 of Professor Richard Boateng's Data Governance Made Easy, published at the University of Ghana Business School, maps the specific mechanisms required to fix this disconnect. When technology and data operate in a strategic vacuum, the result is predictable. Employees adopt unapproved cloud tools, and compliance failures multiply because there are no clear operational boundaries. The required bridge between boardroom strategy and ground-level reality is the IT policy. A functional IT policy performs 3 specific tasks. It gives the entire workforce daily guidance, it aligns technology with business objectives, and it tightly controls the scope of what data is collected and how it is used. An organization's true security profile is not measured by its intentions. It is measured by its mechanical ability to translate those intentions into rigid operational rules. A common governance failure involves treating all compliance documents as equally binding or abstract. They are not. This hierarchy turns theory into action. The top layer is the policy, abstract, mandatory, and board-approved. Below is the standard, translating policy into rigid technical rules like password requirements. Then comes the guideline, offering non-mandatory best practices. At the very bottom is the procedure, a granular, step-by-step operational manual for administrators. If an organization skips any layer in this hierarchy, the translation breaks. Employees are left guessing how to handle data, and guessing creates a systemic vulnerability. Even with a perfect hierarchy, an organization exposes itself to massive legal liability if it confuses the 2 parallel policy fronts it must maintain. We have to separate data security from data privacy. On the left, the inward-facing data security policy protects confidentiality, integrity, and availability using technical controls. On the right, the outward-facing privacy policy answers to customers and regulators. It must answer to specific legal regimes, from international frameworks like the European Union's GDPR to national legislation like Ghana's Data Protection Act 843. Flawless internal encryption cannot protect an organization if its outward-facing privacy policy legally permits it to misuse user data. Security and privacy must operate in tandem. To see how these theoretical frameworks survive contact with global operations, we can autopsy the Samsung Global Privacy Policy. This document outlines their data collection architecture. Right here, under Information You Provide Directly, we see standard inputs: names, dates of birth, and payment information. But looking at information about your use of the services, the collection expands to automated telemetry, unique device identifiers, error reports, and location data mapped from nearby Wi-Fi. This creates a legal problem. Under the GDPR, Samsung cannot process this continuous data stream without specific legal justifications. This section details those exact justifications. Clause 1 relies on performance of contract to ship a product. Clause 2 claims legitimate interests for network diagnostics. Clause 3 covers legal obligations for tax compliance. Finally, Clause 4 mandates explicit consent before they can push personalized advertising. Then there is the geographical hurdle. Because Samsung is headquartered in the Republic of Korea, European customer data routinely crosses international borders. To make that transfer lawful, this section cites adequacy decisions and standard contractual clauses. These are the legal mechanisms ensuring that servers in Korea treat European data with GDPR-level protection. Clicking Accept on a device setup screen activates a legally binding architecture that categorizes data, applies European law, and justifies its movement across the globe. Because technology and global regulation evolve so rapidly, a static corporate policy decays into a dangerous liability almost immediately. Mature organizations prevent this obsolescence by running policies through a 5-phase lifecycle. Phase 1, initiation, feeds into Phase 2, development and approval. Next is rollout, training staff. That flows into continuous compliance and maintenance. Finally, retirement, where obsolete policies are archived. Executing this cycle requires defining dimensions: time triggers, scope criteria, approval methods, accessibility, interpretation of rules, and metrics. Organizations that succeed here manage compliance as an engine of continuous renewal. This lifecycle model meets its hardest test in massive federated institutions like universities or regional hospital networks. The friction is straightforward. Enforcing a single, rigid policy across wildly diverse academic or medical departments chokes operational agility. The University of Michigan manages this through a tiered framework. Draft policies move from an assurance council up to an executive committee for campus-wide vetting. But the engine of their framework is a specific guiding principle: floor, not ceiling. The central university policy sets the absolute minimum standard. Individual colleges are free to enforce stricter rules for highly sensitive research, but they can never implement looser ones. Effective governance in highly decentralized organizations does not demand perfect uniformity. It demands a non-negotiable baseline that local units can build upon to suit their specific operational needs. We started with boardroom strategy and mapped it down through the rigid hierarchy of policy, standard, guideline, and procedure. We separated the inward-facing technical controls of data security from the outward-facing legal obligations of data privacy. These frameworks are how global giants map automated telemetry to international law, and how complex institutions maintain security baselines without killing agility. Data governance is an active, mechanical process. It serves as the operational engine that transforms vulnerability into structural, auditable trust.